Hello, everyone. Today we look at electron orbital diagrams and electron configuration. Before we start, let's review what we did in the last video. So in a paper, pause the video and answer this question. It says, answer the following question using the image below. From the image below, what is the atomic number, number of protons, number of electrons, average atomic mass? Pause the video. Hopefully, you got these answers. This is to refresh our memory as what atomic number is. Atomic number is number of protons. It's in the periodic table, it's above the symbol, okay? So if atomic number is 48, number of protons is 48, remember every element in the periodic table is neutral. Therefore, the number of electrons is also 48. Then the atomic mass is here, okay? Hopefully, you got it right. So to refresh your memory about periodic table, remember that periodic table is numbered in order of atomic number, okay? And this key explains to you information about each square, the elements on each square. It gives you all the information, the atomic number, symbol, all of that, okay? Okay, I would like you to take a picture of this. This topic I normally teach, prefer to teach in class where students participate a lot. And I'm hoping you will participate as you watch. If you do not participate, you will not understand it. It can be very simple and it can be complicated at the same time, depending on how you choose to follow with the lesson. What I have here is called the strange hotel diagram. The strange hotel diagram. Please take a picture of this because I'll be referring you to this picture sometimes when it's not on my screen. Okay? It's called a strange hotel, so you shouldn't be surprised by what I'll describe. So this strange hotel has 7 floors. You say floor 1, 2, 3, 4, 5, 6, 7. 7 floors. And there are 4 types of room. We have S type of room, P type of room, D type of room, and F type of room. 4 types of rooms. S type of room can only have maximum of 2 people stay in it. Okay, in each of these, there's one bed for S type of room. For P type of room, there will be 3 beds. 3 beds, B-E-D-S, I mean, okay? And there'll be maximum of 6 people in this room. D type of room, there'll be maximum of 10 people and there'll be 5 beds. 5 beds. And F type of room, there'll be maximum of 14 people and there'll be 7 beds in this, okay? So there are rules on how to place these people in this hotel. Normally, when you go to the hotel, the receptionist tells you, okay, go to the 4th floor, go to the 3rd floor, whichever one is available. In this particular strange hotel, there are rules on how to place people in this hotel. The first rule, you start from the 1st floor. This is the 1st floor, remember? 7 floors. You start from the 1st floor and you fill this up, which will be maximum of 2. Before you go to the 2nd floor, you fill this with maximum of 2, and then P, this one, this is the second floor, but P type of room, you fill, this will be 6 people, then you have to fill before you go to the next one in order. You have to do that in order. Okay, so the one when you start from the bottom, maximum of 2 people in each of the beds. Okay, and I said there's maximum of these people here. And then another rule is you can only have male and female in each of these. Okay, you can't have male, male, or female, female. It has to be male and female. Okay, you have to have male and female. Okay, when you get to from P type of room, you have to place 1, 1, 1. Okay, you don't put, let's say you have 10 people to place, or rather, let's say 6 people to place. You don't say you 2 here, 2 here. When you get here, you put 1, 1, 1. Then you go back and pair them up. Okay, so you cannot put 2 immediately. Okay, I will demonstrate this to you. Let me show you. This is part of the electron orbital diagram. So you place people from the bottom up. So what you do, you place one person here. Remember, it cannot be male and male, it cannot be female and female. So you place 2 here. Let's say I'm placing 10 people. I want to place 10 people in this hotel. I'm following the rules. I place 2. I start from 1S, that's the first time. Start from the first floor. This has to be filled up with 2 people. This S type of room can only contain 2. I fill this up 2. Okay. I filled up, that's -4. I have 6 people left. Okay. So when I get to fill this up, I'll do this. I cannot. Okay. Then after you fill 1, 1, 1, you go back and pair them up. Okay. Let's say I wanted to do 14 people. Okay, the 14 people to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, you see, I didn't put 2 here. If I do, that's wrong because I have to follow the rules. Okay, so you place people in the hotel following the rules. Okay, that's the strange hotel. Then this is what I mean. Please get your picture. You took picture. I told you to take the picture of this strange hotel so you can reference in it. 7 means 7 plus types of room, S type of room, P type of room, D type of room, F type of room. So S room can contain maximum of 2 people. P room, we have 3 beds, maximum of 6 people. D type of room, 5 beds, maximum of 10 people. F type of room, 7 beds, maximum of 14 people. So how do we place them? You start from first floor, which I demonstrated to you. Male and female in 1 bed. From P type of room, you put 1, 1, 1, then you go back and pair them up. Okay? What does this have to do with chemistry? This is not the strange hotel. I came up with this after I spent a whole month trying to make my students to understand this topic. Then I have to research, and I was able to come up with this story I just told you, with this strange hotel. But this actually is what we call electron orbital diagram. Electron orbital diagram. What that means, this is chemistry. Electron, in place of the strange hotel, I try to use it to explain to you, it's called the electron orbital diagram. So this electron orbital diagram has 7 energy levels. 7 means 7 energy levels. And there are 4 types of orbitals. S type of orbital, P type of orbital, D type of orbital, F type of orbital. Okay. And we have rules on how to, the people we are talking about here, that the people that we place in the hotel are electrons. Electrons. Okay. So what is electron orbital diagram? It is a region around the nucleus of an atom where an electron is most likely to be located. So orbital diagrams are a visual way to show where the electrons are located within an atom. Okay. Then I hope get the picture of this again, please. Now, you can see electron orbital diagram like this also. This is correct. You see, this one is like more of squares. This one is more of that. This is also correct. So if you see it this way, don't think it's wrong. And you see, this is energy level. The energy is increasing as you go up, okay, in this electron orbital diagram. So 7 floors means 7 energy levels. Sub-level describes types of orbitals. That's S, P, D, F. There are 4 types of rooms in Strange Hotel. There are 4 types of orbitals. Okay. Now, when we place electrons in their orbitals, I want to explain things you should know. Every atomic orbital has an energy level. Okay, has an energy level. You see, these numbers, big numbers, are energy levels. Okay. It's normally denoted by n equal to 1, 2, 3, 4. As the energy level increases, the energy of the orbital increases. So orbital here has more energy than orbital here. There should be something showing that it's increasing in energy. So there are 4 types of orbitals. Like in this Strange Hotel, you have 4 types of rooms. There are 4 types of orbitals. There's S, P, D, F type of orbital. Each type of orbital has sub-levels. Remember when I said there's 1 bed, there are 3 beds, there are 5 beds, depending on the this thing. Like S has 1 sub-level, just 1. Okay? P, you see P, when it's P, you have 3. D, 1, 2, 3, 4, 5. 5 sub-levels. F has 7. 1, 2, 3, 4, 5, 6, 7. Okay? So, I'll demonstrate to you how we can place electrons in their orbitals. How we can place electrons in their orbitals. But before we do that, let's also look at more things. Okay, you see here, it says energy level. You see this one is type of orbital. This is number of electrons in the orbital. So I'll explain this later. Okay, you see here, 1 orbital, 3 orbitals, 1, 2, 3, 5 orbitals, 1, 2, 3, 4, 5, and 7 orbitals. Okay, you see 7 orbitals, F sublevel. Okay, now rules. There are rules on how to place electrons in their orbitals. There are rules. Fill orbitals in order of increasing energy according to the Abba principle. According to increasing energy. So you start from the bottom, you fill this up, you go to the next one. Okay, this one is strong because this one was emitted before this. So this is strong. So you start from here, you feed the electrons. Electrons are represented by arrow going up and arrow going down. Remember in the Strange Hotel, I said that you can't have 2 males or 2 females. You have a male and female. That's what this means. So electrons are represented by arrow pointing up, but in this s orbital where you have 2, you have to have the other one going down. It cannot be up. Okay, both of them cannot be going up. You fill this up before you go to the next one. After this, you go to this one. Okay, you see when you get to the p orbital, you see what happened here. There were 4 electrons to be filled up. You don't start 2 and 2 here, which is this. This is wrong. So you have to follow the rules. You put 1, 1, 1, and you go back and fill them. And that's Horn's rule. Horn's rule. Place 1 electron in each orbital of something before you double them up. Okay? Then the Pauli exclusion principle says that two electrons must have opposite spins. Opposite spins. You see this? This is correct. That's opposite spins. Okay. This one, that's wrong. If both of them are down or up, that's wrong. Okay. So that's the rules. I want you to do this activity. Look at your electron orbital diagram and write it in order up to 4F. That means you start from 1s, no comma, no space, 1s. The next one is 2s. Then you go up to 4F and then you stop. Let me go back and show you this again. So you are writing this in order till you get to here, you stop. I don't want you to go all the way. So you start 1s, 2s. You keep on going in order. The energy is this is in order of increasing energy. The energy is going up from 1s is going up and up. So you arrange it in order. So you see that increasing energy. So you, from that picture you took, I can leave this with you, okay? I want you to look at this and then pause it and write this in order up to 4F. I pause the video and do that. Hopefully you got something like this. I told you to stop at 4F. I just wrote the rest, but that's okay. This is what you're supposed to get. And check what you did here and what you did here. Logically, you expect 3D after 3P before 4S, but that's not the case. There's 4S before 3D, and here there's 5S before 4D. This is something you must know. Okay, you must know this order. Okay, you must know this is the way it's supposed to look. I don't mind my students having this in having this order with them during quiz or exam. Okay, it's up to you, but it's okay to have this with you. Okay, now I have to show you how to put electrons in their orbitals following the rules. Or before I do, look at this. Look at the increasing energy. Look at that. 1s, you see this? This one, you look at this, you see? This is like the answer to the activity I gave you. And here the electrons are put in their orbitals following the rules, which I will give you more demonstration of. Orbitals. This is the S orbital, looks like this. P orbital looks like this. C orbital looks like this. And F orbital looks like this. Okay? This, remember, in P we have 3 subshells. These are the 3 subshells for P orbital. Okay? I want you to look at these orbitals.
Orbitals. Orbitals.
I want you to look at the order. Remember the 1s, Before 2s, you just wrote down, okay, the activity you just did. I want you to see a simulation of that. That's 1s. The order you just wrote down in the activity you did, 2s. You can compare it to what you wrote down. Remember, P has 3 subshells and with different orientations. For S. Remember 4s before D. Look at your activity. And D has 5 subshells. Let's place electrons in their orbitals. The first thing you do is to ask yourself, what is the atomic number? Get out your periodic table, look at and find the atomic number of hydrogen. Let's start with hydrogen. So hydrogen has atomic number 1. That means the number of electron is 1 because every element in the periodic table is neutral. So I'll place 1 electron here. This is the electron orbital for hydrogen, okay? If I want to do for beryllium, again, I follow the rules. I'll ask how many valence, atomic number is 4, okay? For beryllium, atomic number is 4, therefore, number of electrons is 4. So I start from first energy level according to the rules, first energy level. Then I place 2 electrons. It has to be opposite spins. I fill this up. There's 2 remaining. I go to the next one, 2s. I fill them up. You see that? So that's electron orbital diagram for beryllium. Let's look at carbon. Carbon has how many atomic number is 6. I hope if atomic number is 6, number of proton is 6, number of electron is 6. So 6 electrons. So I start from 1s. I fill this up, following the rules. Then for remaining, I go to 2s. I fill it up, following the rules. Then I go to here. This is 2p. Okay, 1, 2, 3, 4. Okay, another rule says 5, 6. I cannot put these 2 together, otherwise it's wrong. Okay, because I'm following the rules. This electron orbital diagram for hydrogen, this electron orbital diagram for beryllium, this electron orbital diagram for carbon. Another thing we can ask, if you're going to somebody's house for the first time, you want to, and the information you need is you need their address. So this is where they live. And now, how do we get the address to get there? That's what we call electron configuration. So to figure out electron configuration from this electron orbital diagram, we say 1, 1s. Then there's only one electron here, we put it here. That's electron configuration. Okay, so this is energy level, this is orbital, this is number of electrons. Then for this one, is 1s. There are 2 electrons there. That's, you put it in little subscript 2. And then the next one is 2s. There's 2 electrons there. That's electron configuration. Okay. Then for this one, 1s, there's 2, followed by 2s. There's 2 electrons here. So there's 2 electrons in this energy level in this orbital. Then this one, 2p, 1, 2, there are 2. So this electron configuration for carbon, okay? So now we've looked at electron configuration, we've looked at electron orbital diagram. So what is electron configuration? It's a notation used to indicate the electron's location within an atom. Use it to indicate the electron's location within an atom. Electron configurations are the summary of where the electrons are around the nucleus. It illustrates how electrons can be distributed in atomic orbitals. Okay, that's what that means. I want you to pause the video. I've done the electron orbital diagram and the electron configuration of hydrogen, beryllium, and carbon. Okay. I want you to do D and E. I want you to draw the electron orbital diagram first and then figure out the electron configuration from the electron orbital diagram. Go back and look at the example I did for you. Only this to pause the video and do that. You draw electron orbital diagram and then you write electron configuration from that. Pause the video. Hopefully you got it right. Let's look at it together using this simulation. I told you to do the neon and nitrogen. Let's start with neon. Neon is right here. So let's go here. This electron orbital diagram. We want to place the electrons in their orbitals. So what's the atomic number for neon? If you say 10, that's correct. Atomic number is 10, which is equal to number of protons. Is a neutral atom, therefore number of electrons is 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see that? So if you got this, that's correct. Did you follow the rules? Then this is the electron configuration. Okay, did you get it right? So let's do the other one. You see the rules, you start from 1s. You start from 1s. You fill this up first before you go here, and you have opposite spins. And then you fill this up before you go to this one. You see this one has mass one of 6 because it's p orbital. This one has mass one of 2. And then look at the electron configuration. 1s, 1 is the energy level. S is orbital. There are 2 electrons here. Then the next one, second energy level, S orbital with 2 electrons. This one is also second energy level with p orbital with total of 6 electrons. Okay, let's do nitrogen. Nitrogen, hopefully you got 7 electrons. So nitrogen, 7 atomic number, you see that? So we go 1, 2, 3, 4, 5, 6, 7. Okay? We follow the rules. 1, then we run out. Okay? So first energy level, s orbital, 2 electrons. Second energy level, s orbital, 2 electrons. Second energy level, p orbital, 3 electrons. That's it. Hopefully, you got it right. Okay, this is a practice question. You are doing this. Pause the video. Draw electron orbital diagram first and then write the electron configuration of the following elements. Okay? Pause the video. So for sodium, sodium is 11 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you see the electron configuration. Okay? Then the next one is iron. So we go to the next one, iron. Iron is right here. So iron has 26 atomic number, which is 26 electrons. We place these electrons 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Did you get it right? Hopefully you did, okay? Then we go to phosphorus. Okay, phosphorus. We go to phosphorus. Here we go. We place 15 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You see the electron configuration? Okay, argon is the next one. So argon is 18 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, here's the electron configuration. Okay, then chlorine. Chlorine is, so we go here, get chlorine from periodic table. That will be 17 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. No, 17. I'm wrong. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, 17. That's it. Then the last one is calcium. Calcium. So we go to calcium. Okay, 20 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, no, 20, 20, 20, 20. Okay, so that's calcium. I think I want to redo iron. I think I messed up with iron. Let me redo iron. Iron is, I'm sorry, I messed up with iron. I don't know why I messed up. So I think I messed up with iron. So 26, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. But this is wrong, okay? The order here is not correct. So simulation doesn't have any brain. So you have to move this 4s2 in front before the 3d6, okay? So hopefully you got it right. Sorry about the ion. I messed up there. I don't know why I messed up. Okay. I want to emphasize about ion, the simulation. Number one, I messed up in the simulation. And then number two, you find out that he put 3D before 4S. So this is 4S2 before 3D6. I want to emphasize that, okay? Sorry about the error. Then more practice question. This time you're identifying the which element are the which you look at this and then what element is this? Okay, try to figure it out. Which element have this electron configuration? I mean, electron orbital diagram. Which elements? You can also write the electron configuration so it's not in the question, but if you do that, that will help you to practice that. Okay. Pause the video and answer the question. So here is the answer. This is silicon. Why? Because 1, 2, 3, 4, 10, 11, 12, 13, 14. If you look in your periodic table, it has the atomic number of 14. That means number of electrons is 14. Ion, we just did ion 26. Yeah. Then this is gallium, 31 electrons. Hopefully this makes sense to you. Thank you for watching.